Assalamualaikum and good afternoon. Last week kita dah habis chapter 4. So kita pun dah done with all the reinforced concrete design. Okay, starting from this week, so kita akan proceed with structural steel design. Kita akan belajar about beam, column, connections and also steel roof. But before that, kita akan masuk on the theory first lah for beam and column. Alright, so this is chapter 5 and 6. I combine it together because basically theoretically dia sama lah, but calculationnya slightly different. Okay, the design philosophy for steel design. Okay, the design approach employed the BS 5950. So bukannya 8210 lagi macam reinforced concrete . So this one kita pakai British standard yang lain. 5950 is based on limit state philosophy similar to reinforced concrete design. Okay, so some ultimate limit state to consider are strength, stability, fracture due to fatigue and brittle failure. So strength here actually it just to ensure that macam maksudnya kita buat limit state tu to make sure that it will not yield, maksudnya dia takkan sampai the maximum rupture ataupun buckle under influence of ultimate design load, forces ataupun moment ataupun lain-lain lah, because of actually whatever that coming from the load itu adalah force, and force it also cause the moment. So those things yang actually will cause rupture ataupun buckling of the steel elements . So checking beams, maksudnya untuk beams you have to check for ultimate limit state untuk bending and shear, because of kalau you belajar masa RC design sekalipun, beam susceptible to bending and shear sebab kita kira dua benda ni kan. And for columns, it is compressive ultimate limit state and bending ultimate limit state, tapi if only applicable, because normally for column tak ada bending, jarang ada bending because selalunya penyebab bending ni adalah lateral load lah. Okay, normally it is ultimate limit compressive load yang datang pada atas. So kita for column kita akan check for compressive ultimate limit state. And then for stability, just to make sure the applied load do not induce excessive sway. Okay, sebab stability we must make sure that the elements itself stable. So kita tak nak ada sway ke kanan ke kiri or overturning. If let's say the load is too much, then there's a possibility if let's say the load yang pushing it and the load yang tahan dia tu tak cukup, so dia akan overturn. Okay, there's a possibility of that also. And then we have fracture due to fatigue. This occur to structure that repeatedly subjected to rapid reversal stress. So what does it mean? So macam contohnya, sebenarnya majority of building structure changes in stress ni are gradual, tak banyak. So maksudnya macam ni perubahan loading, senang cerita stress tu sebab load yang cause the stress So perubahan load tu tak banyak, takkanlah macam normally building structure kan, takkan you dah contohnya live load dia perubahan tu tak banyak, maksudnya gradual, dia berubah mungkin naik sikit turun sikit, naik sikit turun sikit, mungkin live load tu bergerak and then live load tu keluar, live load tu masuk live load tu keluar, that kind of thing but it just a slight gradual lah maksudnya. Okay, dia sikit demi sikit dan demi sikit. Okay, normally for building structure lah. However, contohnya kalau ada macam dynamic loading, okay, dynamic loading contohnya what happen to bridges, okay, sebab ada kereta ni getaran tu whatever tu, kan kereta tu tiba banyak, okay, lalu atas bridges, that kind of thing. So itu ada dynamic load, tiba-tiba dia hilang. Dia macam terus datang kejap lalu, datang kejap hilang, datang kejap hilang. So maksud that is dynamic loading. So dia bergerak dengan load tu datang dan pergi dengan cepat. Okay, so itu maksudnya reversal stress tu, rapid reversal stress. So this can cause the fatigue. And then we have a brittle. So brittle failure ni is actually a sudden failure due to brittle fracture. Steelwork is exposed to low temperature. Okay, tapi in Malaysia tak ada lah. Okay, this always happen dekat four season country macam tu. Okay, welded structure are particularly susceptible because of sebab welded structure ni meaning the connection is welded, dia pakai welding. Okay, so connection dia pun steel juga. Okay, but if it is protected against the weather, it is unlikely to occur. So this kind of thing is more likely to occur to welded structure, for example bridges. So yang ada kena this brittle failure. Okay, and then so some serviceability limit states to consider are deflection. So deflection, you quite familiar with this deflection. Deflection ni deflection lah yang you ada kira Y dulu, kalau if you still remember part 2. So that is deflection of beam. Okay, so kita tak nak because of the loading yang cause the deflection. And then we have a corrosion. So corrosion ni probably because of the weather. Okay, so you must ensure whatever that we check. Maybe we can use a certain classes of steel yang available yang ada weather resistant qualities. Contohnya macam oxide skin. Okay, oxide skin ni dia form on surface of steel yang akan prevent further corrosion. And also kalau you pakai this kind of like layer steel ni memang bila datang-datang je dia memang dah macam tu. Maksudnya dia memang ada grade dia, steel grade yang actually weather resistance, but the price is higher lah. Okay, not similar as the normal steel. Normally yang this one kita pakai yang kat luar. Okay, contohnya macam kat bridges because it is exposed to the weather, so you need some weather protection and it costs higher. Okay, and then fire protection. Traditionally casing the steelwork in concrete. So contohnya kita buat macam composite punya structure lah. Maksudnya steel tu, you ada steel. Okay, for example rupa steel tu macam ni lah. Steel tu bukan macam steel bar if you want to know steel tu contohnya macam this one, we have like I section, that kind of thing, or we have like what is it, hollow section macam ni. Tengah ni hollow ada lubang, ada void. Okay, so I'm not supposed to draw like this. I should draw it like this. So this is like the steel, but it got hollow in the center, at the center. Okay, we have like I section, we have like L section and others. Okay, so this is the steel structure the steel elements that we are talking about. We're not talking about the reinforcement bar. Okay, apa tadi I cerita? So on the fire protection so contohnya you boleh in case dia maksudnya you boleh letak konkrit kan terus mendalah ni semua tak dalam ni, but it is heavy. Okay, because of you dah tambah additional weight to encase the steel inside the concrete. Okay, sebab you nak provide protection. This one also you boleh guna to provide protection against the weather and also against the fire, because concrete dia fireproof compared to steel. Ataupun there's other like way alternative. For example, you use a dry sheet material, plaster. Perhaps you can just plaster. You have this kind of you can just plaster the area that exposed. Okay, plaster saja area ni semua, you plaster. Okay, plaster and then plaster directly to the surface of steel ataupun plaster applied to metal lathing. Maksudnya you ada metal, you ada letak another surface of metal and then you plaster lah. And then ataupun you pakai vermiculite spray. So vermiculite spray ni, for example, if you ever went to Gading, I'm not sure other hostel but Gading, dalam Gading tu I'm not sure juga tingkat atas-atas sama ke, but I'm pretty sure dekat bilik dekat rumah RS, resident staff tu, kalau you will see that there is like I section beam yang dia macam ugly tu. Dia macam ada like lapisan yang macam okay. Actually that one sebenarnya dia spray with cementitious material lah, cementitious. Tapi kita panggil dia vermiculite spray ataupun you pakai intumescent paint. Actually this one you belajar kot, masa you belajar theory about steel or whatsoever, how to protect it against fire, but this is what I just explained a little bit. Okay, just to give you idea how to protect against fire lah dengan weather. Okay, intumescent paint ni macam paint biasa, but is a different type of paint that can provide protection against heat ataupun fire lah. Okay, bila dia ada fire tu dia like extra protection. Bila macam dia heat tu macam maksudnya panas so dia punya layer tu dia provide different kind of protection, tak sama macam normal paint So that is intumescent paint. Okay. Other than that, perhaps you can check on your notes from lecturer yang mengajar about steel, ataupun you boleh google lah. There's many other fire protection method for steel. Okay. Okay, so as usual, what we need to do, normally apa yang kita buat bila kita design, this is the ultimate design load, the formula which is 1.4 GK plus 1.6 QK. Okay, this is like the very normal formula that we use. Okay, and then as usual juga kita kira moment and such, bendanya sama sajalah the way we calculate for loading. Okay. But okay, here I want to explain a little bit about the benda yang lain So here you see the design strength PY of grade 43 steel. Okay, grade 43 steel ni the ordinary steel lah yang we normally use in the market. So design strength, so kalau you nampak reinforcement bar, kita panggil dia FY. Mesti ingat strength, kalau if we talk about RC design strength, dia punya simbol adalah FY, but here we call it PY. This one for steel design. Okay, macam contohnya, okay, ini adalah I beam. Kalau you nampak I, dia bentuk I. Okay, I beam. Jadi ini contoh lah. Okay, ada macam-macam lagi bentuk lain. So this is for this kind of steel elements, the strength we call it PY. Okay, and PY ni dia depends on the thickness. Okay, thickness of what is it? Thickness of the some parts of the beam tu. Thickness yang mana? Sekejap ya. Okay, sekejap. Saya tunjuk mana. Tapi okay, kita letak dia T. Okay, so this is like capital T. So T ni yang mana? T ni, okay, you refer to this gambar. So you nampak T tu kat mana? Ini T. Okay, depends on this T. If let's say this T, okay, T besar ni is less than or equal to 16, the PY should be 275. If T ni less atau okay, if T ni bigger than 17. Okay, kalau kat sini 17 sampai 40, dia adalah 265. Kalau ini 41. Why dia tak nak rub? Padam. 41 sampai 63. And here should be 64 sampai 100. Okay. Okay, dia depends on this. Kenapa macam ni? Okay, ini yang dekat factory. Normally, kalau you tengok like all the elements, yang steel elements ya, bukan kita construct dekat site. It is being manufactured in factory. So this is the standard. Okay, so kalau katakan T tu size dia T is less than 16 or equal to 16, PY dia akan dia buat that particular steel pakai strength 275. Macam itulah. Okay, so kalau thickness dia 17 ke 40, PY dia adalah 265. Macam tu So this is the standard. Okay. So here tadi I dah tunjuk. Okay, whatever this is. Okay, steel section are classified in BS 59550 in relation to B over T. So if you notice, where is B, where is T? So this is B. You divide with this big T. Mana big T? Okay, T yang ni. Okay, senang cerita sama jugalah. Atas ni pun separuh ni adalah B. Okay, B you bahagi dengan T of the flange. Flange yang mana? Okay, flange ni adalah yang ni. Area atas ni adalah flange. Area bawah ni flange. Okay, but you kena tahulah apa benda ni panggil. Ni web. Okay, so this is web and that is flange Okay, so nampak colour. Sorry, B over T of the flange and D over T of the web. So of the web yang kat sini. So you nampak D mana? D yang tengah ni bahagi dengan dia punya thickness ni. Okay, so ini sama juga kalau you tengok yang untuk flange. Okay, dia pakai small b, half of this big B, but you have to divide with the big capital T kat sini. Okay, so sama je sebenarnya. Sebenarnya you nak ambil width divide by the thickness. Okay, this one sebenarnya untuk kita tahu jenis classification of beam tu. Okay, beam tu adalah jenis apa. Okay, sebab nanti kita akan belajar on beam classification. So we must know what is B over T and D over T ni lah. Okay, so if you see here, you boleh nampak lah mana satu this is D. So you must know what it is being called Apa yang dimaksud dengan D. Sini bukan effective depth This is like DD. We call it D here. Like small d and big D here. Okay. Okay, kat sini pun lebih benda yang sama, but this one adalah for column. Okay, ini adalah column, ini adalah beam, but sekarang I tengah explain pasal beam lah. Column kita akan masuk on the calculation side later on, so kita akan refer lah to this one also Actually dia sama saja, nama-nama yang kita refer tu sama saja, but the difference is nampak ini dia lebar, column lebih lebar lah, maksudnya lebih balance dari segi tinggi dan lebar dia compared to beam. Beam you will see the beam is higher, but the width is smaller than the height. Okay, so what does it mean? Okay, kalau maksudnya nampak B, D ni apa benda semua ni, you boleh tengok dekat sini. Okay, so sebenarnya I lupa nak beritahu, kalau you nak tengok dekat bawah ni, universal beam. Okay, kenapa kita panggil universal beam? Because dia adalah standard size. Standard yang being manufactured in factory, maksudnya digunakan di semua tempat lah. Okay, so UB, okay, universal beam. So universal beam ni Actually, if you look at here, you akan nampak dia ada macam gang. Gang. Okay. This is like one gang. Bukan gang lah, ada satu siri. Okay, nampak dia panggil serial size. Aduh, I gariskan. Garis pun tak straight. Okay, so contoh I bagi kat sini. 457 191, the serial size here. Look at this serial size. Why dia actually kumpul kan. Okay, ini dalam satu serial size. Okay, walaupun size dia sebenarnya lain-lain. Kalau you tengok D dia tak sama, B dia tak sama, capital B, width of section tak sama, thickness of web tak sama, thickness of flange tak sama, semua tak sama. Okay, but because it is almost sama. Okay, if you see 457, okay, 457 ni sebenarnya refer to apa? Okay, contohnya. Okay, 191 ni kat sini. 457 ni. Tinggi dia. Okay. Memanglah I tahu lah beam tu sebenarnya I section like this. But this is like 457 and this is 191. Okay, contohnya macam tu lah. Okay. So 457, kalau you tengok the gang ni, 457, the depth, the big D. Okay, 457, the big D. The big D is 467, 463, 460, 457, 453. Lebih kurang dalam satu gang dia. So, you tengok mana D? Ni. Betul tak? Ini adalah tinggi dia. Okay, as what I draw here. Tinggi dia. So, satu gang, satu siri. And you see that 191. So, 191 referring to capital B. Okay. So, capital B, ni satu gang dia. 191, 192.8. Kan lebih kurang. 192, 191.31. Although, it's not exactly like 191, but it almost 191. So, dia duduk dalam satu siri. So, it is easier. Takkanlah you I nak beli beam yang size, yang depth of section is 460.2, 191. B is 191.3. Web thickness is 9.9. We don't do that. We just read the serial size here. So, kita akan tahu beam mana kita nak maksudnya nak pakai atau nak beli, because of it is easier to label and it is easier to memorize and it is much easier if we have the family. Maksudnya ini family dia lah. Dia dah group together in one family, one series. Lebih senang nak refer. Okay. Okay, tadi I cakap apa? Okay, this one is capital B. So, betul lah. Nampak tak? So, atas ni adalah capital B. Okay. So, 191 tu, this one, 191, and then 45, tadi? 7. Okay, 457 adalah dia punya big D here. Like that. Okay, so dia under satu siri. So, how you going to like, for example, if you want to choose this beam, contohnya, you nak pakai beam ni. You nak pakai this beam. So, how we going to write it? So, it is 457, 191, 74, UB. Okay, so we already know kalau 74 ni adalah UB ni maksudnya universal beam. So, kita tahu, kita nampak je kata, oh, UB. Okay, so it is UB lah. Ataupun kalau you tak tulis macam ni, you don't put UB, you letaklah dia punya berat sebenarnya. Kilogram per meter UB. Dia juga yang tulis macam ni lah. Okay, 74 kilogram per meter, because of 74 to refer this mass per meter. Okay. And then UV, which is universal beam. Ni bukanlah dia ke bawah, ni bersambung It is actually bersambung. Okay. Ya ampun. Fauzi betul. Okay. Dia bersambung. Okay, itu I nak explain lah. So sebenarnya dalam ni untuk setiap satu ni, okay, mana-mana you ambil lah. Okay, setiap satu ni semua, dia ada dia punya characteristics masing-masing meaning ratios of local buckling dia different, second area dia different. Memanglah different because size dia berubah, size dia tak sama. Bila size berubah, mestilah tak sama dari elasticity, mestilah tak sama daripada plasticity, tak sama thickness dia pun tak sama, so semua jadi lain. So it depends on section mana yang you pakai, so you must aware on that. So here nanti I bagi juga the handout, inside the, bukan handout lah, inside the handout akan ada lah this table that you can refer. So if you see kat sini pun benda ni sama saja. This is the same jadual yang sama, it's just that dia continue. This is the smaller size, so you nampak 457, 152 yang dekat atas ni. Okay, it's actually sambung dekat bawah lah, 457, 191. Lepas tu maksudnya it's a continuous table, but satu muka surat tak cukup. So I separatekan dia. Alright, I hope you understand on that part, because bila kita tak buat calculation, we don't really faham sangat lah how to refer to this table and so on. Then kita akan buat calculation later. Okay, I hope that you can look at this and then you try to familiarize with this table because table ni memang kita akan sentiasa refer. Okay. So contohnya kalau nanti bila kita calculate, dan kita akan kena select UB yang sesuai, maksud universal beam yang mana kita nak pakai. Okay, and then we have to do some classification. We need to know that beam yang kita nak pakai tu which one, maksudnya in which beam atau column. Maksudnya ni ada dua-dua sebab kita akan buat classification. Untuk column pun kita akan buat benda yang sama lah. Okay, but this one I cerita secara teori je lah. Okay, we need to classify the beam. Beam tu adalah plastik ke, compact ke, semi compact ke, slender, because it always depends on jenis beam untuk you design macam mana. Okay, local buckling can be avoided by limiting the width to thickness ratio. So maksudnya yang tadilah, if you see that tadi ada bagi tahu pasal B over T ataupun D over T tu ya. Okay, okay, inilah dia breadth B tu, B kan, yang half of yang B. Okay, so this is like the B, small b divided by the thickness, so this is T lah. Okay, because of you punya ni macam ni, I don't know how to. Okay, and then D over T, so this one untuk flange, ini untuk web. So web tu D tu yang dalam ni, and the thickness is this one kan, that one lah. Okay, so kita kena tengok dari segi thickness, width to thickness ratio of each element of cross section. Maksudnya flange dengan web ni subject to compression due to moment or axial load. Okay, so ada 4 classes of classification, which are plastic, compact, semi compact and slender. So if let's say you design as a plastic, so kalau you nampak sini, maksudnya you akan allow rotation. Maksudnya design you must allow rotation. Okay, dia akan jadi, you kena design, ini adalah design with rotation the higher with rotation. Okay, and kalau you tengok dekat bawah ni, makin lama slender ni makin kurang, semi compact kurang compact. Okay, but here, okay, maybe confused lagi, kita tengok kat belakang. Okay, apa maksud dia? Okay, kalau you nampak kat sini ada ME, MP. Okay, apa maksud ME, MP ni? ME ni adalah elastic moment, MP tu adalah plastic moment. Okay, a property of the structure section. Okay, plastic moment is defined as moment at which the entire cross section has reached its yield stress. So kalau you masih ingat, I pernah explain dalam chapter 1 part 2 pasal elastic and plastic. So kalau tak ingat kena refer balik that graph. So that graph tu sebenarnya bagi you idea sikit what is elastic and plastic ni. Which plastic moment is defined while elastic moment is defined as the moment at which the entire cross section has reached its elastic limit. Okay, apa maksud elastic limit? Ingat balik, elastic limit tu maksudnya lepas dia daripada elastic, dia dah lepas dia daripada elastic limit you punya element, so maksudnya beam you for example dah tak boleh return to dia punya original kalau dia being pull ataupun maksudnya ada load yang put on your elements tu, maksudnya atas your beam tu, when we remove it dia takkan return to the original original shape. Okay, tu maksud elastic kan, kalau dia dah exceed the elastic limit. Kalau dia masih dalam elastic limit, dia akan return to the original shape. Okay, tu maksud dia. So yield stress ni apa? Yield stress ni sebelum dia fail lah. Okay, lama-lama atas lagi pada yield stress, dia akan lama-lama dia akan fail, patah lah. Okay, atas lagi dari itu dia akan dia okay lagi, tapi lama-lama dia go down and then dia patah macam tu lah. Okay, refer balik pada that graph yang I pernah tunjuk dalam masa part 2. Okay, so here first is class 1 plastic. Okay, when you design maksudnya the section is plastic. Okay, maksudnya section yang you guna tu adalah section yang plastik. Okay, plastic hinge can be developed with significant rotation. Okay, apa maksud plastic hinge ni? Deformation of part of beam whenever plastic bending happens. So maksudnya deformation lah. Okay, hinge kat sini maksudnya there's no capability to resist moment. So maksudnya kalau plastic hinge ni dia akan behave like standard hinge. So maksudnya dia akan permit free rotation. Okay, maksudnya you design ni you akan benarkan rotation bila you design dia as plastic. So all members must be this type. Apa maksud all members tu? Maksudnya flange dengan web must be this type. Sebab okay, mungkin you confuse kot bila flange cakap. Ada juga flange yang bukan plastik, web je plastik. Sebab kita kan kira untuk dua-dua, satu B/T and D/T. Okay, so kita akan guna this two ratios ni, maksudnya B/T and D/T. Kita akan tengok which, this one untuk flange kan, and this one untuk web. Okay, so kita akan tengok flange ni adakah plastik, web ni adakah plastik. Macam tu lah. Adakah dia compact? Okay, so itu yang kita akan tengok. Okay, and then class 2 compact, full elastic moment can be developed. Okay, but local buckling may prevent production of full plastic moment. Okay, elastic moment ni, okay, tengok balik elastic moment apa maksud dia kat atas ni. Okay, elastic moment is defined as moment at which entire cross section has reached its elastic limit. Okay, maksudnya dia boleh develop entire cross section tu boleh develop moment dia tu boleh develop sampai reach its elastic limit. Okay, tapi local buckling may prevent production of full plastic moment. So local buckling ni maksud dia ini. Confuse sikit lah benda ni. Okay, local buckling, if you see here, this is local buckling. Okay, ini kalau dekat web. Kalau dekat flange, okay, you akan nampak dia macam ni. Okay, so this is kind of local buckling. So sebenarnya bila kita provide like up until like full plastic moment, maksudnya the elements itself is very macam cakap the thickness B/T ni, okay, is very high. Maksudnya ratio dia tak banyak beza. Saya nak cakap B dengan T ni ratio dia tak banyak beza B dengan T ni. Sebab B you divide by T kan. Okay, tak banyak beza. Okay, jadi nombor dia very low. Okay, so bila dia lebih low, so maksudnya dia boleh support a higher moment. Okay, maksudnya kalau kita kata plastic moment, so maksudnya plastic moment ni memang moment yang tinggi lah. Okay, tapi bila compact ni maksudnya dia dah kurang lagi, dia baru sampai full elastic moment tapi dah ada local buckling. Maksudnya because of maybe the thickness tu tak cukup untuk resist daripada buckling. Okay, so dia akan buckle dulu, tetap tak dapat sampai full plastic moment. Okay, and then semi compact, cross section can develop their elastic moment capacity, but local buckling may prevent full elastic moment capacity. Okay, cross section boleh develop elastic moment capacity tapi tak sampai full. Maksudnya it will not reach its elastic limit. Okay, maksudnya tak, the entire cross section tu mungkin tak dapat reach its elastic limit. Okay, so maksudnya the moment that maybe the structure can resist will not as much as full plastic moment lah. Okay, tak banyak lah. Okay, and then slender contains and elements subject to compression due to moment or axial load. Local buckling may prevent the full elastic moment capacity from develop. So slender ni yang paling kurus. So senang cakap plastik ni dia gemuk. Compact ni dia kurang gemuk, semi compact lagi kurang gemuk, slender ni kurus. Okay, because of sebenarnya kita tengok pada B over T dengan D over T ni. Okay, nak senang faham lagi, so senang tengok sini Okay, so sebenarnya you nampak ni ada plastic, we can see here this is plastic, this is compact, this is semi compact. Yang lepas daripada this one adalah semua adalah slender. Okay, dah keluar daripada section 15, daripada 15E, 120E, 40 E ni tak, E ni constant sebenarnya, dia tak ada nama, kita panggil dia constant lah, dia bukan elastic. Dia bukan E tu elasticity, bukan itu bukan elastic, ini adalah constant lah, senang kita panggil dia constant Okay, nampak ni constant. Constant ni apa? Dia ada 275 divide by PY. So PY tu depends lah. Kalau ingatkan tadi kita tengok dekat dalam table tu, kalau katakan T is less or equal to 16, PYU adalah 275. So you ambil value 275 ni, you letaklah dalam ni, so you akan dapat 1. Okay, so 275 bagi 275 square root, tetap 1. So 9 darab 1, 9 lah. So bila you nampak, kalau dia plastik, okay, element which exceed this limit are to be taken as class 4 slender cross section. So ini yang saya cakap Okay, so maksudnya sekarang ni, ini adalah limit dia. So maksudnya value, kalau you nak kata dia adalah plastik, B over T, for example seperti sini, tengok B over T kat sini, must be less than 9E. Nanti baru dia jadi elastik. Okay, kalau dia lebih daripada 9E, mungkin 9.5 ke, dia adalah compact. Kalau dia 14 ke, dia adalah semi compact. Macam tu lah maksud saya. Maksudnya nanti kita akan refer, sebab kalau you masih ingat tadi ada tunjuk yang stable kan, sebenarnya okay, you boleh tengok sebenarnya B over T, D over T ni semua kat sini. Okay, semua dah ada. Kalau tak ada pun sebenarnya you boleh kira manual, you ambil je value B, small b, mana small b tak ada sini. Tak ada. Okay, tak ada, memang you just boleh je ambil small b is like half of b lah sebenarnya. Half of b you divide by the big T here, 36.6. So 420.5 divide by 2, divide kan dengan 36.6, you dapatlah 5.04. Okay, tapi kat sini table ni dia dah mudahkan you lah, you dah boleh jumpa. So you nak tengok section tu jenis apa kan, you tak tahu. Okay, for flange je, okay, for example you ambil ni, you tengoklah 4.92. B over T dia. Okay. So B over T 4.92. 4.92. Obviously it is less than 9 constant. Sebab contohnya I cakap tu PY kita yang ni lah, 275 ni. So memang obviously dia less than 9 constant. So dia adalah plastik. Okay. Itu dia. Itu contohnya. And then also we have web where neutral. Ini adalah untuk flange. Okay. So flange untuk beam kita tengok kat sini. Okay. Flange, web untuk beam kita tengok kat sini. So D over T. So D over T sama juga, you refer to here, contohnya 35.8. Okay, 35.8. Comparekan dengan 80 constant ni lah. So 80 darab constant 1. So 35.8 obviously is less than 80. Okay, so bila less than 80, kita pun dapat dua-dua design kita ni adalah, dua-dua elemen dalam kita punya beam tu adalah plastik. Itu yang maksud saya. Hopefully you understand that. Tapi nanti bila kita kira baru kita lebih faham lah. And then, okay. So after kita dah classify kan dia, we need to know the shear capacity. Maksudnya, capacity you punya beam, how much it can support. Okay, PV kat sini adalah shear capacity. Okay, ini being taken daripada BS, bukan saya buat formula sendiri. Okay, so formula dia is 0.6 PV AV. Okay, PY AV. So PY ni PY lah, steel strength tu, and then AV ni adalah area. Depends on jenis apa you punya beam tu lah. Sebab we are talking about beam I section ke, you have like roll, I, H and channel section, load parallel channel, ataupun welded I section ke, rectangular hollow section ke, welded box section ke. So you have a lot of type of section ni sebenarnya. Kalau you tengok yang table yang saya tunjuk tadi tu, sebenarnya dia ada banyak jenis. Okay, yang sebab kita just cover I section sahaja. Okay, but in design actually it can be like box section, it can be hollow section, it can be solid bar, it can be like circular hollow, macam ni ada lubang kat tengah. Okay, it can be many types of steel elements. Okay, ada banyak. Okay, but okay, because kita belajar satu saja, so this is A. Okay, kita belajar ni je, roll, I, H and channel section, load parallel to web. I tak boleh sebut. Okay. So we just in the syllabus I just cover this one only lah. Kalau you ambil civil, you kena buat semua. Okay, so I just cover up until this part. Okay, so just replace je A ni dengan TD. T ni apa, D ni apa, you pun tahu, you boleh tengok pada you punya section. Section ni yang mana satu. Okay, so masukkan value, you akan dapat capacity dia. And then you akan compare dengan FV, which is the force, shear force daripada yang loading yang you kira previously. You akan compare dengan this one. Okay, so kita akan tahu shear capacity dia lah. And another thing, okay, provided that the shear force does not exceed, tapi bila kita nak kira tu, okay, bila kita nak kira tu, kita kena tengok juga shear force ni does not exceed 60% of shear capacity. So maksudnya sekarang yang you kira PV ni, okay, you kena darab lagi dengan 0.6. Okay, 60%, 60% adalah 0.6. So you akan dapat some value kat sini, and then baru you boleh compare dengan PV, whether it's bigger ataupun lagi besar. Kalau dia less, maksudnya dia adalah low shear, means that shear force yang produced by the load can be resisted by the PV, okay, shear capacity of the beam, okay. And then kita kena tengok juga moment capacity. So MC here means moment capacity. Ada tak? Tak ada tulis Okay, so this is moment capacity. Okay, so moment capacity ni kita nak tengok satu untuk resist loading, another one untuk resist moment. Okay, so kita tengok capacity beam tu, whether it can resist the moment that produced by the load. Okay, using the formula of PYS. Okay, S here means plastic modulus. Okay. Oh, dah ada kat bawah ni. Tak apa, tulis lah. Plastic modulus. Okay. Dah ada kat sini actually. And Z, kalau tengok kat sini adalah elastic modulus. But if let's say you just for class 1 plastic or class 2 compact cross section, sebab that's why you kena buat classification tu dulu. Maksudnya you kena classifykan konkrit lah dah. Classifykan steel you jenis apa. Dia adalah compact ke, semi compact ke, plastik ke. Bila you dah ada dia punya classes ni, baru you tahu which formula yang you akan guna. Sama ada this one atau this one. Kalau katakan plastik, so this is the one. Okay, so ikut yang mana satu. Okay, and then tapi lepas you kira benda ni, okay, you dapat moment capacity, you kena make sure that dia punya capacity ni, contohnya kita pakai class 1 plastik lah. Maksudnya kita punya konkrit, so konkrit lagi. Kita punya steel, tak boleh move on dari konkrit hari ni. Kita punya beam tu, okay, kita punya beam tu kita nak contohnya it is plastik, kita dah tahu, okay, dia punya classification adalah plastik, so we using this formula. Okay, kita must make sure that it is less or equal to 1.2 PYZ. Okay, Z kat sini adalah elastic modulus, you kena kira lah. So you check dulu MCU less than 1.2 PYZ, maksudnya okay. Bila dah okay, baru you compare dengan moment yang being produced by the loading. Okay, it's not that hard, tapi dia macam jalan kerja dia panjang. Okay, so I think sampai situ saja. I will end this lecture here. In the next video, I will explain how to calculate. Okay, thank you so much. Have a nice day, everyone.